Hello guys, so today I'll be explaining the math quiz of term 1 week 5. So which of the following functions is one-to-one? Whenever they say one-to-one function, which test do we use? We use horizontal line test. Always before we have to check if it is first a function. So first you do vertical line test to verify if it is a function, and then if it is not a function, we do the horizontal line test. Now, if we do the horizontal line test for this one, we notice directly it's not a function because there are more than one point available on the same horizontal line. Also for here, it's not a one-to-one function because there are more than one point available on the same horizontal line. So on the same horizontal line, there is more than one point, so it is not a one-to-one function. Here for this one, you will also notice that there is more than one point on the same horizontal line, so it is not a one-to-one function. Here, if you draw the horizontal line here, 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 wherever you draw it, you will see that it is a one-to-one function because there are no 2 points on the same horizontal line. If you try here, we already found that it's not a one-to-one function because there are more than one point on the same horizontal line. And finally, this one, it is a one-to-one function because there are no 2 points on the same horizontal line. Now, question number 2. Which of the following functions is even? Whenever they ask us for an even function, what do? We have to use the equation fx is equal to f minus x. That means if we took, for example, x squared and we replaced x, we're gonna get x squared. But if we replaced minus x, we're gonna have minus x to the power of 2, which will then give us x squared. So x squared and x squared are the same, so that means this function is even. So remember, anytime you see even, you use fx is equal to f minus x. Now let's substitute and let us see, is this even? So we already have fx, or ux in this case. Ux is equal to x squared minus 1. What if we did u minus x? Will it be the same? We're gonna then have minus x to the power of 2 minus 1, which is then also x squared minus 1, and this is also equal to this, so that means the first one is even. Now, anytime you see a number without x, without any variable, any whole number or any real number without a variable is even. So any real number is even. Okay, so this is for this one. Now, if we did for the wx, we have already wx, and we know that the equation is fx is equal to f minus x for even. So we have wx, let's take w minus x. It will give us what? 1 minus x to the power of 3. Now the exponent of 3 is odd, so it won't do anything to the minus, and so then we're gonna get 1 minus and minus become plus 1 plus x to the power of 3. So this one and this one are not the same, so it is not even. Now for the px, we remember fx is equal to f minus x. So we have x minus 1 to the power of 2, okay, or we have minus x minus 1 to the power of 2. If you factor this, if you expand it, you're gonna have x squared minus 2x plus 1, and here you're gonna have minus x squared plus 2x plus 1. So they're definitely not the same, so this is not even. Sorry, this one is not even. Okay, now for this one, for the vx, we keep in mind fx is equal to f minus x. So Vx is equal to x minus 1, v minus x is equal to absolute value minus x minus 1. These two are not the same, so it is not even. Okay, now finally for the qx, we remember fx is equal to f minus x. So qx is equal to the absolute value of x minus 1. So q minus x is equal to absolute value of minus x, minus 1, which is equal to the absolute value of x minus 1. So this and this are equal, so this is then even. And so we have even. Question number 3. Before they asked us even, now they asked us for odd. Whenever we have odd, we have 3 steps to do. First step, we have to check if fx is equal to f minus x, or in other terms, substitute with minus x. Then second, if fx is different than f minus x, okay, we say it's not even. Then the third step, we multiply result by minus. So first, what do? We check if fx is equal to f minus x, or we substitute with minus x. Then we see if fx is different than f minus x, then we say it's not even, and we proceed to step 3. If it is even, we don't proceed, okay? So if it's not even, we proceed to step 3, and then we multiply the result by minus. And if you multiplied with minus and it's equal to fx, then it is odd. So let me recap one more time in a clear way. First, substitute with minus x. Second, if fx different than minus x, say it's not even. Then third, multiply by minus. And then fourth, but I didn't put it fourth last time, I merged it with third. Fourth, if we multiply what? We multiply the result by minus. If what we get is equal to fx, then we say it is odd. I think we can better understand if we did some examples. For example, the first one, we have px equals x minus 1, okay? If we substituted the x with minus x, we are gonna get minus x minus 1. Definitely, these two are not the same, so we know it's not even. Now, to check if it's odd, we multiply the full equation by minus, and so then we will get what? We will get x plus 1. But still, x minus 1 is not equal to x plus 1, so it's neither even nor odd, so we say it is neither. Now the second one, let's substitute x by minus x. So we're gonna have minus x minus x to the power of 3, okay? So definitely, if we solve it further, we're gonna get minus x plus x to the 3. Definitely this one and this one are not the same, so they are not even. We said if they're not even, we multiply the result by minus. So now, what will we get? We will get x minus x to the power of 3. So this one and this one are equal, so it is odd and not even. So this one is odd. Next one is this. Let's substitute with the x's by minus x. So we're going to have minus x, absolute value minus x, which is the same as minus x absolute value x. So look, these two are different, so it is not even. Now, we said if it's not even, we multiply it by minus. So if we multiply it by minus, we're going to have minus times minus x, the absolute value of x, which will then give us x, the absolute value of x. Look, this one and this one are the same, so then it is odd. That means this one is also odd. You can directly stop and say that the two correct options are these, but I want to continue so I can make it even clearer. So we have x minus 1, substitute with minus x. We're going to have minus x minus 1, okay? These two are different, so it's not even. And even if we multiplied it by the minus from outside, okay, it would change the signs inside the absolute value. They will become x plus 1. This one and this one are not the same, so it's neither even nor odd. Now we said any number without a variable is even, so if it is even, it's not odd. And finally, this one, we're gonna replace the x with minus x, so x squared minus 1, replaced by minus x, so minus x squared minus 1, which will also give us x squared minus 1. So this one and this one are the same, so it is even, and if it's even, it's not odd. So that was it for question number 3. Question number 4. This is very important. Given fx is equal to 2x minus 3 and gx is equal to x squared minus 1, find the value of minus 2gf. Just follow in the order it's given. They gave you minus 2 here. So you substitute it in what? In the g. So you take the minus 2 and you substitute it in the g. So now it's g minus 2 is equal to minus 2 squared minus 1. Minus 2 squared is 4, so 4 minus 1, it is 3. So now we have gx, or g minus 2. I'm gonna keep it as gx. It is equal to 4 minus 1, which is 3. I'll repeat again. You have in the g, you substitute the x with minus 2, okay? So you substitute the x with minus 2. So gx is equal to minus 2 to the power of 2 minus 1. So it will give us 4 minus 1, which is 3. So we can take it as what? Gx is equal to 3. Okay? It's equal to 3. Then they told us what? Inside of the function f, you have what? You have the function gx. Okay? So our function gx, we said it's equal to 3. Okay? That means we're gonna be replacing the gx in this by 3. So now we're gonna have f3. Put it here. f3 is equal to 2 times 3 minus 3, which is 6 minus 3, which is also 3. So let me do it one more time. We have minus 2, we should replace it in g. So we replace it, we're gonna get 3, okay? Then we have gx that we need to replace in f, and we know that gx is equal to 3. So we replace the gx by 3. So now we get f3 is equal to 2 times 3 minus 3. So 6 minus 3, which is 3. Question number 5. This is very important. Look, we have x then first we have g round fx. Let's do it like this. We're gonna go from the right to the left, okay? We're gonna start, we have fx. So that means we replace the fx by x. For every x in here, we put x in it. So basically, it's gonna be the same. 2x plus 10, okay? Now, since we're going from the right to the left, we're gonna now replace our value into the g. So whatever value we get here, we're gonna replace it into g. Our value for the fx is 2x plus 10. So now we're gonna replace every x in the g by 2x plus 10. So now, if this is the equation of gx, okay, and we need to replace the x in the gx by 2x plus 10, we're gonna have 4 times 2x plus 10 plus 1. So then 8x plus 40 plus 1. Then we're gonna have 8x plus 41. So here we have 8x plus 41. Again, I will repeat. We're gonna go from the right to the left. First we start. We need to put inside of the fx. We already have it, or if you want to substitute, you can substitute. You're gonna get the answer 2x plus 10. Okay? Then you're gonna substitute the fx into the g. So what's our result of fx? It's 2x plus 10. Now we're gonna replace the 2x plus 10 into the gx. Okay? That means for every x in the gx equation, we're gonna put 2x plus 10. So that means 4. Instead of the x, we put 2x plus 10, and then we put plus 1. So then it becomes 8x plus 40 plus 1, and then 8x plus 41. Question number 6. Which of the following are one-to-one functions? We said whenever we have one-to-one functions, we need to do the horizontal line test. But before that, this question is important. Why? Because one of them, some of them are not functions. So before we see if it's a one-to-one function, we have to check if it is a function first. How do we check if it's a function? We do vertical line test. So first we will check if it is a function before we check if it's a one-to-one function. So for example, this one, we're gonna do the vertical line test. It failed the vertical line test, so it's not a function. How about this one? We do the vertical line test. It passes, so it is a function. Same for this one. It fails, so it's not a function. This one as well. It passes, so it is a function. And this one, it fails, so it is not a function. So that leaves us with only 2 possible answers, which is this one and this one. Now, they need us to check if it is one-to-one. So what do? We do the the horizontal line test. This one passes, so it is one-to-one. And this one, it also passes, so it is 1-to-1. So this and this are one-to-one functions. Now, question number 7. The greatest possible value of k for which the function h whose graph is shown below is 1-to-1. Okay, basically, they need you to make this graph into a one-to-one graph. We said if it's one-to-one, okay, first of all, we check by the vertical line test to see if it is a function. It passes, so it is a function, okay? Now, we do the horizontal line test to see if it is a one-to-one function. It fails, so it's not a one-to-one function. So we need to find a point on the line, okay, where it will make h into a one-to-one function. So if you notice, if you draw it from here, from 6, okay, and then you draw the horizontal line, there are no points that meet, okay? So you have to choose the lowest point or the point where there are no 2 points on the same horizontal line. In this case, it is 6, okay? Again, I'm gonna explain how we did it. First, we're gonna draw all the horizontal lines. Then we're gonna choose the point where no 2 points are on the same line. For us, it is the 6, okay? It meets at the 6. It is the 6 where the 2 points don't meet. And so then we have to split it in half from here. And then if you do the the horizontal line test for this one, it's 1 to 1. And if you do it for this one, it's also 1 to 1. So again, I'm gonna repeat the greatest possible value for k to make this a 1 to 1 function. We're gonna take the point in where there are no 2 points on the same line and on the same horizontal line, and it needs to be the lowest point. So for us, it is 6. Question number 8. A function is defined. Did I put 6? 1 second. Yes. Question number 8. A function is defined by the points indicated by dots on the grid below. Okay. Which of the following points, if removed, makes the function 1 to 1? We said if it is 1 to 1 function, we have to do the horizontal line test. Here we have 2 points on the same line. We have Q or U. So you either remove Q or U. So if you put U in the exam, it's correct. And if you put Q in the exam, it is also correct. Question number 9. This one, it came in the exam last time. This is very important. It's coming. So how do you solve this? You take the number that is behind the x. For us, the number is -2. And then you take the opposite of the number. So what's the opposite of -2? It is 2. So now the value of k is 2. Okay? So I remember in the exam, I'm just gonna write some other. It's gonna be, I remember that the value was -5 squared plus 10. Something like this, I think. Okay, what we needed to do, we needed to take the -5, okay, and we take the opposite, and so now the answer was supposed to be 5 in that exam. Now question number 10. We said whenever we see G round F and then something, we're gonna do from the right to the left. So we're gonna start with the 0. The 0, we're gonna replace it in the F. So go to F and replace it with 0. That means for every x, we are gonna put 0. Okay? So 5 times 0 plus 3, it's gonna give us 3. That means our fx is equal to 3. Now, we need to substitute our fx, all of this, into g. We said our fx was 3, and so now we're gonna substitute it into g. So instead of, like gx, okay, we're gonna substitute the x by the fx, which was then 3. So now it's gonna be g3, okay, is equal to 3 squared plus 1, which is equal to 9 plus 1, which is then 10, okay? I'm gonna repeat again. We're gonna start from the right to the left. 0, we replace it in F. After you replace it in F, you're gonna get that fx is equal to 3. Or f0 is equal to 3. Okay, let's take it as f0 is equal to 3. It will be easier. Then we're gonna take the f0 and we're gonna put it into the g. Okay? So our f0 is 3 and we're gonna put it into the g. So now, instead of the x, we're gonna put 3. Okay? And for every x in the equation, we're gonna put 3. So that's gonna be 3 squared plus 1. So g3 is equal to 9 plus 1, which is then 10. So the value of this is 10. Question number 11. This one is very, very important. So we said we're gonna start by solving from the right to the left. So we're gonna start with the x in g. You can choose to replace it, but if you don't want to replace it, you're gonna take gx as it is, okay? So gx is equal to 2x minus 9, okay? Now they told us put the gx inside of the f. Basically what they're saying is f gx, okay? They're saying it like this. So we're gonna put the gx into the f. That means for every x in the f, we're gonna put the value of gx, which is 2x minus 9. That means 2 times 2x minus 96, plus 1 over 2x minus 96 plus 4. Now, you can solve it and get the answer, but directly, if you don't want to waste time, you read they are asking for the domain. So whenever they're asking for the domain, we're gonna look at the type we have. Here we have a fraction. So whenever we have a fraction and they're asking for the domain, we take the denominator, okay? And then what do we do for the denominator? We make it different than 0. Because we know in a fraction, the denominator cannot be 0. So now we have 2x minus 96 plus 4 is different than 0. 96 plus 4 minus 96 plus 4 is minus 92. Okay, so now we're gonna have 2x minus 92 is different than 0. So then 2x is equal to 92, and then x is equal to 92 divided by 2. Here this becomes 4, and this becomes 6. So that means the domain is all numbers except for 46. Okay, I will repeat again. We're gonna start from the right to the left. So whenever you see round, you can directly be like, okay, it means f, you open brackets, and then gx. So we have to substitute the gx into the fx. Okay, that means for every x in f, we're gonna put the value of gx, which is 2x minus 96. So 2 times 2x minus 96 plus 1 over 2x minus 96 plus 4. Okay, then they're asking for what? They're asking for the domain, and we know that the domain of a fraction, we should make the denominator different than 0. Then after solving, we're gonna get that the x is different than 46. So the domain is the set of real numbers with one number excluded, and this 46 is the number excluded. Question number 12. This is repeating, okay? Directly you can start from the right to the left, so you can go like this, tack, 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 or you can do f, okay? You open the brackets, because instead of the round, we're gonna pretend there are brackets, and then we put gx inside. So that means what? We have to substitute the value of gx into f. So every value of x in the equation of fx has to be substituted with 10x plus 3. So 4x plus 1, we're going to substitute every x with 10x plus 3. It becomes 4 times 10x plus 3 plus 1. So 40x plus 12 plus 1. So then 40x plus 13. Okay, that was for question 12. Now question number 13. Let fx equal to 2x squared, blah, blah, blah. Okay. Here, look what they did. They told us f round g 1. Okay, we said that we're gonna put, instead of the round, we're gonna put brackets around the other two. So f brackets g1. Okay, or we said we can start from the right to the left. So that means we have to substitute 1 in g. So for every x in the g, we need to substitute it by 1. So 1 plus 3, that means g1 is equal to 4. Now, we need to substitute the g1, okay? We need to substitute it in the f. So we know that g1 is 4. So we need to substitute it in the fx. So that means for every x in the value of fx, we need to put 4 in its place. So f g1, okay, is equal to 2. Okay, we said for every x we're gonna be putting 4. 2 times 4 to the power of 2 minus 5. So 2 times 16 minus 5, so 32 minus 5, which is then 27. Okay? I'm not gonna repeat this one. I want you guys to practice more. You can either go from the right to the left, or you can go replace the round with brackets. Question number 14. Let fx equal to 5 over x minus 7 and gx equal to 3x minus 5. What number is not the domain of this? So how do we do this? We're gonna start from the right to the left. So the g, we're gonna substitute it in the f. There is nothing to substitute in the g, so we take the g as it is, and we're gonna put it in the f. That means for every x in the equation of f, we are gonna put the value of gx, which was 3x minus 5. So 5 over, instead of x, we're gonna put 3x minus 5, okay? And then minus 7. They're asking what is not in the domain of f round g. We have a fraction, so we take the denominator different than 0. Then we have 3x minus 12 different than 0. 3x different than 12, x different than 4. So it's all the real numbers except for 4. So 4 is not in the domain of f round g. But 4, yes. Question number 15. A computer is programmed to pick whole numbers from 1 to 100 inclusive. What is the probability the next number the computer picks is a multiple of 30? So if it is a multiple of 30, okay, we have from between 1 to 100. Let's list the multiples of 30. We do not count 0 because it's from 1 to 100. So then we have 30, then 60, then 90. Then the next one is gonna be what? 120, but 120 is bigger than 100, so we do not count it. So we only have 30, 60, 90. These are 1, 2, 3. 3 values out of 100. Okay? So 3 divided by 100 is 0.03. So our answer is 0.03. Question number 16. 2 balanced dice are rolled and the sum of the outcomes, blah blah blah, is noted. Let x denote any of the outcomes. Okay. Do not focus on this. Instead, focus that 2 balanced dice are rolled. Any dice, how many sides do we have? We have 6. So if 2 balanced dice are rolled, how many possibilities do we have? We have 6 times 6, okay? Which is then 36 possibilities. So again, we have 2 balanced dice are rolled, and in a dice we have how many possibilities to roll? We have 6. So if 2 dice are rolled, that means we have another possibility of 6 happening. So we're gonna have 6 possibilities and another 6 possibilities, and in math is equal to times, or in math is equal to plus. Okay, remember, and is equal to times or is equal to plus. Okay, so we have 6 and 6 possibilities, so 6 times 6, which is then 36. This is the total number of possibilities when we roll the dice. Okay, so it's not the sum of outcomes, no, it's the possibilities. Okay, now they're telling us what's the value of px is equal to 4. So first of all, what's the total number of possibilities? 36. صح? Okay, we know that the total number of possibilities is 36. طيب, when we roll a dice, how many possibilities is there to get 4? We can get 1 plus 3, or we can get 3 plus 1, or we can get 2 plus 2. Is there anything else? No. So we have 1 plus 3, 3 plus 1, and 2 plus 2. These are 3 possibilities out of the 36 possibilities to get 4, that is. So then if you simplify it, it's gonna be 1 out of 12. So here this is 1 out of 12. Now this is very important. Please focus on this one. What is the value of p greater of possibility of x is greater than 4? Okay? We know that the possibilities in total are 36. So our denominator has to be 36. Now, there are many ways of doing this. You can take all the numbers greater than 4, which was here. If you come from here, we have 2, 3, 4. The numbers greater than 4 are 5, 6, 7, 8, 9, 10, 11, 12. This will take so much time if you take all of these possibilities, okay? So this is very, very important what we're gonna do here, so please focus on this, okay? So we said the total number of possibilities is 36. They are telling us they need the possibilities of x being greater. X is the outcome. The outcomes being greater than 4. So instead of wasting our time for doing the big amount of numbers that are greater than 4, we know that the only numbers that are 4 and less are 4, 3, and 2. These are in the outcomes. We have 4, 3, and 2. Next step, what do we do? In how many ways can we get 2 in a dice? We can get it only 1 plus 1. Okay? So there's only one possibility for getting the 2. For getting the 3, how many possibilities are there? We have 2 plus 1, and we have 1 plus 2. So that is 2 possibilities. For getting the 4, how many possibilities are there? We have 3 plus 1, we have 1 plus 3, and we have 2 plus 2. So for getting 4, we have 3 possibilities. If you noticed, it's increasing. We have 1, then 2, then 3, then it will increase more. Like you will notice it's a pattern, you know? And then it will stop, then it will decrease. Okay? So for now, we're only gonna focus that 2 has 1 possibility, 3 has 2 possibilities, and 4 has 3 possibilities. Okay? So, in total, how many possibilities are there for the numbers that are 4 or less? It is 1, 2, 3, 4, 5, 6. So, the total number of possibilities that are for 4 or less are 6. Now you're gonna say, but Amanda, they need the possibility of x greater than 4. Why did you take the ones that are 4 and less? It's totally opposite of what they're saying. Now this is the point. This is why we took the opposite. So we can do what? We can do 1 minus 6 over 36, okay? Which will be then 36 over 36 minus 6 over 36. Okay, so we're doing the total number of possibilities minus the opposite of this possibility, okay, So we can get this possibility, which will be then 30 over 36, and if you simplify it, it is 5 over 6. Okay, so I will recap. The total number of possibilities of rolling 2 dice is 36. Okay, the total number of outcomes, or like the outcomes, can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? So they're telling us in the first one, what's the possibility that x is equal to 4? We know that for 4 to happen in the dice, we have the possibility of 3 plus 1, we have the possibility of 1 plus 3, and we have the possibility of 2 plus 2. So that's 3 possibilities, okay? We're gonna put it over the total number of possibilities, which is 36, so that is 1 over 12. Now this one, if we're gonna follow the way of solving this, it's gonna take too much time. So what do? We're gonna find the opposite, okay, which is x is less than or equal to 4, so it's gonna be 2, 3, 4. We're gonna find the possibilities for each one, so in total the possibilities of 2, 3, and 4 are equal to 6, all right? And then we're gonna put it over the total number of possibilities, which is 36. But we're not finished here. Here we took the opposite. We found the possibility of the opposite. But to find the possibility of this, we're gonna do 1 minus this value. So it's gonna be 36 over 36 minus 6 over 36. And then you get 30 over 36, which is 5 over 6. That's for question number 16. Question number 17. When rolling 2 biased dice and observing the sum of the 2 numbers the dice land on, there are 11 possible outcomes. Okay? The probability of obtaining a sum of 12 is 1 out of 36, and the probability of obtaining a sum of 11 is 2 out of 36. So what's the value of k if the probability of obtaining a sum of 10 or less is k over 12? Okay, they need what? They need the probability of obtaining 10 or less. So x has to be less than or equal to 10. If we're gonna count it, we're gonna have 10, 9, 8, 7, 6, 5, 4, 3, 2. These are too many numbers. Whereas if we're gonna take the opposite, which is x is greater than 10, we're gonna have only 2, 11 and 12. It will be much simpler for us. And they already told us the probability of 12 and 11. It is 1 over 36, and the one for 12 is, and the one for 11 is 2 over 36. Okay, so we're gonna find this probability. So the probability of x greater than 10. Okay, it's gonna be, we only have 2 values, 11, either 11 or 12. And we said whenever we have or in math, it becomes plus. So the probability of 11 is 2 over 36 plus the probability of 12, which is 1 over 36. Then we get 3 over 36. So now the probability of x greater than 10 is 3 over 36. طيب, now to find the probability of x less than or equal to 10, we take 1 minus the opposite. So 1 minus 3 over 36. Then it's gonna be 36 over 36 minus 3 over 36. Okay, so then it becomes 33 over 36, and if you simplify it, it is 11 over 12. So they need the value of k, so then the value of k is 11. Question number 18. Now we reach geometry. So how to do this geometry? Okay, There are many ways of doing it. Okay, the way that I prefer to do it is like this. If you notice this one, okay, it is a diameter, صح? So that means CA or CBA is 180 degrees, okay? Then we have an interior angle, which is BDA. And we know that the rule for the interior angle, it is the measure of the arc over 2. So if our interior angle is 56, then our arc is gonna be 56 times 2, which is then probably 112, okay? So we found the measure of this arc over here. It was 112. Now, they need us to find what? They need us to find the measure of BAC. Okay, the measure of BAC is this angle. It's also an interior angle, okay? We know already that this one is 112. So to find the measure of arc BC, minor arc BC, we do 180 minus 112. It's gonna be 68. So the measure of this arc is 68. And we know the rule of the interior angle is measure of the arc over 2. So it's gonna be 68 over 2, which is then 34. So we found the measure of the angle, which is 34 degrees. Question number 19. So in the figure below, the line A is tangent to the circle at H and forms an angle of 74. Okay, this may look like one of the hardest questions, but it's very, very easy. How do we know? Look, whenever we have a tangent and a secant, okay, this is an interior angle, okay, to which arc? To this arc, okay? So, for example, this tangent and this secant, okay, they form an interior angle to which arc? To this arc. So basically, the arc that they touch, it is the arc that they are interior to. So this one and this one, they are interior to which arc? The minor arc, or I'm gonna say, I'm gonna put this point P. So I'm gonna say arc HPG, okay? Now, if you notice, also, this triangle, I forgot what's this letter, or I'm gonna call it W, HWG, okay, triangle HWG, is also touching which arc? This arc. So they're both touching arc HPG, yes? So again, this interior angle, okay, I'm gonna color it red. This interior angle is touching this arc, okay, and this interior angle is also touching the same arc. So if they are both touching the same arc, okay, and they're both interior angles, and we know that the rule of interior angles is a measure of the arc over 2, and they're both they're both touching the same arc, okay, then that means what? It means that they are both the same value. So x is equal to 74. What rule can you derive from this? We can derive the rule that if you have two interior angles, so two interior angles touching the same arc, okay, then they are equal. This is the one of the easiest definitions. So x is equal to 74. Question number 20. in the figure below, S is tangent to the circle R. The measure of the angle formed by S and MR is X. Okay, this is very important also. Angle X, interior angle X is touching which arc? It's touching this arc over here. But which interior angle is also touching this arc? This interior angle MNR is also touching this arc over here. So we can say that MNR, angle MNR is equal to X from the rule that we took from the previous question. Now if you notice, we have a triangle over here and it's an isosceles triangle. And in an isosceles triangle, the base angles are equal. And also in a triangle, the angles, like all of them, are equal to 180. So 50 plus this angle, which we're gonna call Y, and this angle, which we're gonna call Y also, because they're the same angle, because the base angles are equal in an isosceles. So plus Y is equal to 180. In other terms, 50 plus 2Y is equal to 180. 2Y is equal to 130. So then Y is equal to 65. So now we have the value of MNR. It is 65. So angle MNR equal angle X equals 65 degrees. See how simple it is? It may look hard, but it's one of the simplest examples to solve. Now, in the figure below, the measure of arc WU is 50 degrees, while the measure of arc FV is X. This is a very important, it's a new one. Okay, how do we solve it? We're gonna take this interior angle. It's the same as this one. Why? This one and this one are equal because vertical angles. Okay, keep this in mind. This angle over here and this angle over here are equal. So, the rule for this is that this interior angle, which is the same as this one, okay, 70 degrees is equal to the measure of this arc plus the measure of this arc over 2. So X plus 50 over 2. So in other terms, the measure of this type of interior angle is equal to the measure of both the arc it's touching. So it's touching this arc and it's touching this arc over 2. I will repeat again. The interior angle, okay? You notice that they're the same value and they're touching 2 arcs, yes? So because they are the same value, we can say what? The interior angle, okay, which is 70, is equal to this arc plus this arc, so X plus 50 over 2. So 70 times 2 becomes 140. 140 is equal to X plus 50. X is equal to 90. That's very simple. We found the value of X, which is 90. Question number 22. This may seem hard, but it's very, very easy. If you remember, okay, central angle is equal to the measure of the arc, and interior angle is equal to the measure of the arc over 2. And we know that in a cyclic quadrilateral, I'm not gonna write quadrilateral, okay, opposite sides are supplementary. Okay, so we have this quadrilateral, it is cyclic, okay, meaning it's an inscribed quadrilateral, okay, so that means opposite angles are supplementary. So angle C plus angle D is equal to 180. Then they need us to find what? They need us to find the measure of ADB, or basically the measure of angle D. They're saying how much is it? We know that angle C plus angle D is equal to 180. To find angle C, it is an interior angle, so we need the measure of the arc. If you notice, we also have a central angle, which is O. And we know that the measure of the arc is equal to the measure of the central angle, so it is 104. So the measure of the interior angle is equal to the half of the measure of the arc, so it's gonna be 52. If I'm not mistaken, 104 divided by 2, 5 to 52, yeah. So the measure of C is equal to 52. Substitute 52 plus angle D is equal to 180. Angle D is equal to 180 plus, minus 52. So 180 minus 52. This is 8, this is 2, and 1. So we got that angle C plus angle D is equal to 180. Angle C is 52 and angle D is how much? 128. So very simply, we found the measure of angle ADB, which is 128 degrees. Question number 23. This is very, very important, okay? You remembered in question 21, we added this one and this one over 2 to get the interior angle. This was because what? They are opposite arcs, okay? Now, if it is facing each other arcs, we have a different case, okay? So this interior angle, this exterior angle that we need to find, what do? We do the big measure or the major measure and minus the minor or the small measure over 2. So again, the exterior angle is equal to the big measure 106 minus the small measure 46 over 2. So it's going to be 60 over 2. So it is 30. Again, the rule for the exterior angle is the major arc minus the minor arc over 2. So 106 minus 46 is 60 over 2, which is then 30. Question number 24. In the figure below, CD is a tangent to the circle D. They're telling us the measure of arc F is 152. They need to find the measure of X. Okay, this may seem hard, but it's very, very simple. We said anytime we are finding exterior angle, okay, what do? We do the big measure, I'm gonna say major, minus the small measure, which is minor, over 2. But us, we need to find the minor. What did they give us? They gave us the major, which is 152, minus the minor that we need to find, okay, over 2. So we have 2 unknowns. We cannot work like this. We need to find the minor. How do we find the minor? We know in a circle, the angles are 360 degrees, okay? And then we have 152 and we have 132 here. So 360, I'm gonna call this minor arc Y. So 360 is equal to 152 plus 132 plus Y. 152 plus 132, 284. So 360 minus 284, sorry, my bad, here it's 5, so here it becomes 7. So the answer is 76. The measure of the minor is 76. So now we can solve because we have the measure of the minor, 76. Okay. exterior angle, okay, is equal to the major minus the minor over 2. What's the major? It's 152. Minus the minor, which is 76 over 2. We're gonna get 76 over 2. And 76 divided by 2 is gonna be 38. So the value of x is 38. So then the measure of arc DF is 152. And we solved it and we got that the value of x is 38. Question number 25. Question number 25. If the measure of minor arc MN is x, what's the value of x? They need the measure of which arc? This arc. Okay? How can we find it if we are given the value of this angle? Very simply, we can find the measure of the arc that it touches. We do 110 times 2, we get 220. So in a circle, we have 360. So 360 minus 220, we get 140. So instead of also dividing by 2 and etc., we already found the measure of this arc, which is 140. I will repeat again. We have the measure of this angle. We found this arc, 220. In a circle, it's 360. So 360 minus 220, we get 140. And directly, that's the measure of our arc MN. So it is 140 degrees. Question number 26. This one is very, very interesting. It's very, very important. They need the value of x. We have an exterior angle. We know that the rule for the exterior angle is major. Why do I keep on writing major like this? Major minus minor over 2. Okay? So we have only the major, it is x. But we also need the minor. We know that in a circle, the measure of the angles are 360. If you notice, these are two tangents, okay? So they're touching the bigger and the smaller as well, okay? So again, exterior angle is major minus minor over 2. We have the major, which is x, and we know that in a circle, the measure of angles is 360, or the measure of the arc is 360 degrees. So 360 minus x is equal to which value? This one. So the measure of this arc is 360 minus x. So major is x, minor is 360 minus x. Okay? But of course, we're gonna put the parentheses because minor is 360 and minus x, and then the minus is by itself. So x minus 360 plus x, okay, over 2. We don't forget the over 2. And it's equal to what? The exterior angle, which is 46. So then, 2x minus 360 over 2 is equal to 46. 2 times 46 is 92. So 2x minus 360 is equal to 92. 2x is equal to 360 plus 92. 2x is equal to 452. 452 divided by 2. No, 4. 6. We're gonna get 226. So I will repeat. We have an exterior angle. The rule of exterior angle is what? Major minus minor over 2. Okay? So we have the major, which is x, and we know that in a circle the arc is 360 minus x. So we know that in an arc the measure is 360. So then the measure of this minor arc is gonna be 360 minus x. I will repeat this again. The major is x. In total, the circle is equal to 360. Okay, so if this is x, then this is 360 minus x. Okay, our major is what then? X. And our minor is 360 minus x over 2. All of this is equal to 46. Then we substitute. Sorry, we don't substitute, we do. We solve it further. We're going to have 2 times 46 is 92 is equal to x. Here this becomes x minus 360 plus x. So 92 is equal to 2x minus 360. Bring 360 to the other side. We're going to have 452 is equal to 2x. So then x is equal to 226. Very done and very simple. So let's double check if there's any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day, and I hope you understood and do well in your AMS, which is next week.